Hello, my name's Joe. Welcome to my workshop. Today I'm going to show you how to use posebone.matrix to align two bones perfectly because I've been metaphorically bashing my head against the wall for the past, say, 4 hours trying to solve a seemingly simple problem. And I figured it out, and I'm going to share that solution with you so you and I never have to wrestle with it again. See, in order to achieve perfect alignment between two bones, there are a couple ways to go. You can constrain one bone to another, then apply that constraint, which generally works, but if you're using the linking workflow, you have a problem because the linking workflow doesn't really like when you apply constraints through code. Anyways, the other cleaner approach is to rely on the matrix data belonging to each posebone. So I can set this posebone's matrix to be that posebone's matrix, and then we're good, right? Well, we start to have problems when we do some things in between capturing the matrix data, then applying it after some changes occurred. For instance, here I'm troubleshooting the follow rotation system in the Kinematic tool to get linking to work. The follow rotation system allows a limb to follow the rotation of its parent. When I turn off the follow rotation system, the limb continues to move with the parent but doesn't follow its rotation. Notice how the position of the limb doesn't change as I toggle between these two modes. This is how it's supposed to work. Now let me show you where I was a moment before I figured out the problem. I had ripped out the parts of my code that create and apply constraints. I had added the code for the matrices, which I'll detail in just a moment. But when I went to switch between follow rotation modes, this repositioning you see is the problem I was facing. And I obviously want this limb to remain perfectly in place as I turn follow rotation on and off like we see here. This happens because, as the doctor says, quote, refreshing the viewport basically evaluates the animation data. Changing the animation data doesn't immediately cause this evaluation, end quote. Let me show you real quick how all this plays out in practice. This custom property drives the entire follow rotation system, and when I toggle it between 1 and 0, the position of the limb changes. But if I do the same thing through code, say I change it from 0 to 1, well, nothing happens in the viewport until I click in the viewport. This is what happens when changing the animation data through code, but not updating the viewport. And in my code here, I am changing the animation data, but I'm not updating the viewport. So we have to update the viewport somehow. So let's walk through this code real quick. Then I'll show you how I update the viewport. And the solution isn't the typical context.viewlayer.update solution that has seemed to be a reliable solution for me in the past. So first I capture the matrix data of this bone before any changes occur. I use matrix.copy because if I were to use just .matrix, I would only be referencing this value even as it changes. Instead, I want to store the value as it is right here. Let me show you what I mean. If I store this posebone's matrix into the variable m and check the value, it's at its default as expected. Then when I move, rotate, and scale the posebone, I'd expect that the value at m would remain as the default that I stored, but it's not. Instead, it's still referencing the posebone's current matrix value. Let's start over with the copy approach. To actually capture the data as it is, include .copy after matrix. I move, rotate, and scale the posebone, call m, and m is still holding the default value just as I want it to. Compare that with the posebone's current matrix value. Then I change the value of the follow rotation custom property right here. This is really what creates a chain reaction and affects the position of everything else because changing this affects drivers that control permanent constraints. Then I keyframe the change to the custom property. Then I set the posebone's matrix back to the matrix I captured originally. Then I keyframe this change and then do some other stuff. Now here's the interesting thing. This on its own won't work because, as the doctor mentioned, the view layer and the dependency graph don't update until after a script runs. And so the typical solution, which has worked in other parts of my code, is to update the view layer for the current context with context.viewlayer.update. But for some reason, that's just not working here, as you can tell when I make the change and try it out. So after asking Google about it, the solution is simply to just set the frame to the current frame I'm in, which triggers a viewport update, the sort of viewport update I was expecting from this. Now, when I save my code, reload my script, and then test the follow rotation, the matrix that I captured and applied is working as intended. What's really, really important is where you put this viewport update. For my needs, it's immediately following the change that affects the location of things in the viewport and the keyframe insertion, and before applying the matrix. But if I apply the viewport update after applying the matrix data, but before keyframing, you'll see that's also an issue. So my point is that it's situational. In other cases, I was doing this sort of viewport update after applying a matrix. So to review, use matrix.copy when capturing matrix data, update the viewport with something that reliably works, like simply setting the frame to the current frame, then place that viewport update in the crucial spot. Okay, good luck. Bye!